Okay, so I guess we'll get started now. So again, welcome everyone on this second day of sessions at Connect. This is the first session of the day, so I hope you enjoy the keynote today. I'm here to talk about security, so I hope you guys are excited to talk about this topic in the morning. I'm here with Arun from Vormetric, so maybe Arun, you can introduce yourself as well.
Sure. So I'm here with Vormetric, and we're here to talk about data security for Couchbase. So how many people like it when a security compliance auditor walks in with a request to? Probably not too many. So that's, we're here to talk about that, what drives some of their behaviors and how we can help you guys address some of those requirements specifically. And I've been at Vormetric for a couple of years, work on technology partners, and Couchbase is one of our big partners in the NoSQL space. So looking forward to this session and sharing some best practices and techniques with you guys.
Cool. So a rough agenda for this talk is going to be I'll start with talking about giving you a Couchbase overview of why security is important for NoSQL databases. It's quite a hot topic nowadays. And also some of the key drivers for security, why a lot of you may be asked by, let's say, a chief security officer or other, let's say, IT staff within your organization to kind of enforce security. And then I'll pass it on to Arun to kind of explain how Vormetric works and how our joint solution works with Vormetric to kind of encrypt your data. So with that, so why is NoSQL security important? So with all these sessions that we had yesterday and even many of them today, you probably noticed that we're talking about performance, we're talking about multi-dimensional scalability, and all these great things that we've done within Couchbase Server. So a lot of these things give you things like enable you to handle data coming in with a high volume, definitely with a high velocity as well, because you have data from different sources at high speeds. And finally, variety. The fact that you are using a NoSQL database is because you also have data coming in with different formats or different fields, and that's why you use JSON as the underlying data format. But in addition to all of this, if you look at just sample a lot of apps today, you'll see a lot of apps process a lot of unstructured data. And when we talk about unstructured data, we mean emails, videos, tweets, posts, all kinds of data which have so many different attributes and fields which are also constantly changing. And so one very important property of your data there is value. So your data is also valuable. You might be storing sensitive information in the data, and that's the last, I would say the 3 V's, and the last V is the value there, the 4th V. So when we kind of sample the field and we're talking to customers, we see what are the common security questions we asked. And I think in my presentation yesterday, we kind of talked about some of the controls that Couchbase has internally to kind of answer many of these questions. So some of the common questions that we get from our customers are, which ports are open through the firewall? What vulnerabilities exist? Is there any admin data separation? Is your data encrypted in the cloud if you're just backing up data in the cloud or just using running Couchbase in the cloud? Is XDCR secure when you're putting data across to another data center? Is sensitive data encrypted? Or even backups encrypted, or what if an operator steals a disk? So there's so many different questions that we get, and what we're here to answer, I think the red ones are the ones we kind of talked about yesterday. But what we're going to answer through Vormetric and our solution with Vormetric is the ones in blue. So with that, I'll just pass it on to Arun.
Great. Thanks, Don. So first, let's do a little bit of setup here. So, I think Bob, a couple of days ago, talked about the digital economy and data is exploding. And the subset of that data is very sensitive data. And if you think about the digital economy, the new disruptive companies and some of the legacy companies, there's very high attach rate to deploying in non-traditional areas. So typically, data was located in enterprise data centers, remote offices, but now they're going to public-private hybrid clouds. They're also people using big data to go proliferate information there, and there's lots of it. I mean, I think it's pretty obvious. There's a lot of data being out there, and part of it's sensitive data. And there's mandates around protecting that sensitive data. And so let's take a look at a couple of the specific use cases, or double-click on cloud and big data. And this is analyst data we collected. So if you look at one of the biggest concerns for deploying workloads in the cloud, it's data privacy and security. So large enterprises, customers want to make sure that they have that data locked down if it's going to be in a public cloud or private cloud or hybrid cloud. and data security is one of the top concerns. The other one is big data. I mean, so big data is very agile. You get a lot of information. You can do things very quickly. But one of the biggest growth inhibitors, again, is security and privacy. And a lot of times, you know, when I talk to our field guys, it's ex post facto. People went through written a really good app. They're going to deploy it out in the cloud. They're using Couchbase, but then there's a fire alarm that goes off that said, we can't put this in production until we protect it. So a lot of times, you know, it's done at a last minute or ex post facto of doing everything. So, you know, one of the things hopefully we can leave you with is try to make your jobs easier by baking it into the part of the process. And I think we can talk about a couple of techniques about doing so. And then, again, so as this data set moves out to the cloud and to big data, some of the traditional IT security challenges don't subside. So how many people in here have heard about Anthem, Target, Sony Pictures Entertainment? The list goes on and on and on. So what we're seeing in probably the last year, executive mandates around thou shalt protect sensitive data, and sensitive data in this case could be PII, privately identifiable information, could be personal health information, and if you look at HIPAA, it's very prescriptive around what needs to be protected, and then also intellectual property, et cetera. So there's a lot of executive anxiety that's manifesting from the CISO to the CIO to a lot of folks in this room on being able, you know, thinking about security. And what's driving that again is nobody wants to be the next big headline, go into lawsuits. I mean, I think I looked at the Target, they're still in litigation. So it's a long and ugly process. So they want to put some controls in place to help mitigate that. So again, so compliance is still going to be a big factor. So PCI is very prescriptive. HIPAA is very prescriptive. And they're also, I guess the other thing that gets taken into account is state regulations around privately protecting data privacy laws. So California has a data privacy law, Washington, et cetera. And some of these are very punitive the fines range based on the amount of data that's exposed or breached. So again, all this stuff still exists whether you're in the cloud or, you know, deploying workloads in the cloud or using big data, and that won't go away. And how many of you guys are familiar with this company FireEye? So so big in the data breach space, but one of the other kind of attack vectors is if you ever listen to Kevin Mandia speak, I think he was on 60 Minutes, a great speaker. One of the other big threat vectors is the insider threat. So if you think about when data gets stolen, it's either a rogue insider or it's a malware or a piece of APT. And what they go after is those root accounts or privileged user accounts that have access to godlike access to data. And that's where they kind of glean all this stuff. So that's another big thing to think about, and then I'll talk about that. But that's a big source of data breaches and why people are getting hacked. So if you look at, you know, this is kind of the Vormetric-centric kind of slide, but sensitive data is not just in NoSQL databases. It's also in structured databases, unstructured data. Imagine like if you call up your healthcare company, they say, you know, ask your name, your social security number, all that stuff's being recorded and stored somewhere, and it's all sensitive data. So example of what unstructured sensitive data looks like. So basically there's multiple use cases or multiple places where sensitive data is deployed. And so we have the ability, again, using a centralized management platform to address multiple encryption use cases, because it's not just going to be Couchbase. Maybe you have some other structured databases somewhere, a data warehouse somewhere, et cetera. So we have the ability to, on an enterprise-wide basis, to address those encryption use cases. You probably don't want a separate product for each single use case. And so we have multiple techniques to do that. And if you look, so we're going to talk about, there's two techniques we're going to talk about today. Transparent encryption. That's where basically there's no changes to the app or to the database, and that's why it's called transparent. And then field level encryption or app level encryption. These are probably the two techniques we've seen very common with Couchbase and NoSQL in general in being able to protect data. And then we also have, I think Don put up dev and QA, so we have the ability to redact private information. So if you have data that goes from dev to QA, but maybe has some sensitive information, you can tokenize that data. That's another way data analysis is done. So in a nutshell, I think we help address multiple use cases, and we'll go into a couple of those today. I think I covered topic one, where what is sensitive data and where is it located in multiple places, and we talked a little bit about topic two. Actually, I think I covered most of this, but we can. So I'll just skip past this one right here. and go to, so first we're going to talk about Vormetric transparent encryption. So this is really, as developers or as folks that want to have least intrusive encryption, this is probably the trade-off here is it's really quick to implement, and it encrypts data and it shuts out to OS privileged users. So I'll go into this a little bit more detail, but that's a benefit to this. So again, the reason we call it transparent is there's no changes to the application or database. So I'm going to look at this in 2 layers. So the first layer is the architectural layer, and the second layer is a policy layer. So from an architectural perspective, hopefully you can see that dotted line here, but this, the way we have a hub and spoke architecture. So on the left-hand side, there's a data security manager, or DSM, and this is really where the security policy is owned and the keys are stored and the audit logs are stored. And so that basically prescribes under what criteria data can be accessed. On the right-hand side, there's a box that represents a server. In this case, it could be a Couchbase data node, which includes indexes and data, et cetera. And so we're deployed, if you look at that V with a circle, it's actually an agent that sits at the file system, and it actually implements a policy that's dictated by the data security manager. And essentially, what we do from an architectural perspective is we're sitting at the operating system of the file server that's connected to persistent storage. And so we're transparent to the database, we're transparent to the application, and so so basically, there's no changes to the database, no changes to the application. You basically get the encryption up and running fairly quickly. And so from a file systems perspective, or a file server perspective, we support Unix, Linux, Windows, all the major operating system. And on the storage side, we support multiple file system types, and those are 2 big dependencies. So in a Couchbase context, this could be a Couchbase data node, and that agent is enforcing the policy from that data security manager. And so one of the biggest questions we get asked still continuously is, encryption's a math problem. How's this going to impact my performance? It's great, it's transparent, I don't have to make any changes, but is it going to impact my performance? So we basically work with Intel, which is another company here, and we offload a lot of crypto functions to the hardware. So they have something called AESNI, so you can hardware optimize the encryption and key management. And so typically, the mileage is going to vary, but typically we see about less than 5% impact. So again, so the application user is not going to feel it, that it's in the background, neither is the database vendor. So, so it's really optimized for performance, and some of the performance kind of concerns have gone away, but that used to be there. Now, if you look at basically the policy layer on this, so we're looking at essentially three population sets. So one is an OS privilege user. The second is a Couchbase process and service user. And the third, on the right-hand side, is suppose this data is out in the cloud. The other population you need to be concerned with is cloud administrators, storage administrators, et cetera. Because if you put something in Amazon, there's administrative users that have access to the data to be able to do what they need to do. And so so basically, for a Couchbase process and server, they have a legitimate use of the data, their intended user. So essentially, you allow them access to the data, and then you decrypt it for them. And essentially, they can do their job and go along their way. On the OS privilege users, these guys have a legitimate access to the data because they need to do their backup job or whatever, but they shouldn't be able to see the data. So you can allow them access, but you blind the data to them. So literally, all they see is ciphertext with some headers that allow them to kind of do their job, but not yet see the data. It's probably the biggest scenario this conjures up is Edward Snowden, right? He was an OS system admin. So he had full access to data. He could view it, and he could copy it. He could move it, do whatever he wanted. But the fact that he could actually see the actual data, that was one of the big vulnerabilities there. So and again on the cloud, you can think of that an extension of the OS privilege user, where again you give them access, but you blind the data. And we refer to the time as blinding data. And so basically, and if you kind of loop this back to one of the biggest threat vectors to data breaches, it's that OS privilege user and the fact that they actually have unfettered access to data. And again, but they're not an intended business user. So how do you solve that problem? And again, this is one technique that you can use to do that. And additionally, from a Couchbase context, it's not just the data nodes that have valuable information, but if you think about reports, configuration files, logs, sometimes that's even more valuable than the database files themselves because they contain aggregated information. So being able to protect all that information So essentially this, and then the other big thing is we offer, you want to have the key separate from the data. So we offer, so the data security manager here is providing key management. So the key is residing separate from the data. So if you think about it as in cloud context, you're a company that owns a security policy and owns a key, but your workload's out in the cloud. So you explicitly can dictate when somebody can access and view the data because you own the security policy. So a lot of customers, like this, and because they can deploy stuff out in the cloud. And again, going back to one of the inhibitors of cloud, it's data privacy and security. And cloud is, whether it's cloud providers directly or SaaS vendors, it's a huge driver for our business. And the other one I think Don talked about yesterday was audit logs. So the ability to capture all this granular information on who's accessing data and what they're doing, we can feed that into any SIM of your choice or a Splunk dashboard. So you can look in, a lot of times that's what security folks and auditors want is reports and alerts. I mean, the fact that you're actually monitoring that data access. So that's our what we call transparent encryption, and it's also known as file level encryption because it's the file layer, and it provides that not only encryption but that ability to shut out the OS privilege user or blind the OS privilege user. All right, so next I'm going to talk about application encryption or field level encryption. So here, and so Don talked about separating admin access from data access. So this addresses that part of it. So essentially, you kind of move that agent up from the file system to the application. And what you do is you can encrypt certain fields of data. Just pick, say, social security number. Say an application makes use of social security number or some other data, but they want to encrypt that. So essentially, the agent would sit at the application layer, and using a PKCS11 library that we have available on that data security manager, you can make calls to that and encrypt certain fields of data. And this is what's called field level encryption. And here, it's what you're doing again is you're blinding the database user as well, because it's the application that's determining that's actually doing the encrypt and decrypt. So you kind of, from a security perspective, you're raising the level of security you have essentially. And so basically, it works pretty much the same way, except you're doing the key calls there. But here's an example. So this is with Couchbase. So this is a Couchbase using a Couchbase client. So essentially, if you look at the animation, you have an application that calls using an API. Again, it's a PKCS11 API. Makes calls to the data security manager to encrypt certain fields of data to get the key to encrypt it. And then when it sends the data back to the Couchbase server or the Couchbase client, and it's encrypted at that point. So it's encrypted in the database layer as well, in addition to the file layer. All right. So next, let's take a look at how this goes into practice. And so I took some screenshots of our GUI, and I'll show you kind of the scenarios we talked about. And again, the 3 population sets that I referred to earlier, which is an intended user, say it's a Couchbase process, a privileged user, an OS privileged user, and then third is anybody else. It's basically any unauthorized user in general. So if you look at, and this is pretty much a rule set that most customers have. It's very simple. People typically have anywhere from 3 to 5 rules, and essentially, if you look at it, it almost looks like a firewall. For those folks that are familiar with firewalls, you have a set of criteria, a resource, a user, and again, we integrate with LDAP and AD, so we pull the user groups from there, and then you can bind them to a process, saying this user using this process, allowing them to and under this action, what's the effect? So you define a criteria and the effect. Again, the 2 main effect points are: do you allow them access, permit them, and do you apply a key? Do you allow them to actually see the data? And so essentially, that's what you apply is a criteria. I mean, the effect from the criteria. And you can get very granular with this. So you can, you can make sure that you literally dictate the level of trust you have for people to view and access data. And so then there's an intended user, and then privileged user, et cetera. I'll go into this a little bit more detail, but I just want to give you an overview of what the typical rule set might look like. And again, this works in a Couchbase context as well. So here, I mean, what do you do? Typically, what you do is you define a user set list, right? So basically, we create 2 user set lists. One is a Couchbase-centric one, and another one is a root one. We talked about the OS root level user. So essentially, you create 2 user lists here. And then what you do is you basically define some criteria and what the effect is here. So again, for your intended user, you permit them access, you apply a key. Your privileged user, you permit them access, you don't apply a key, you blind the data, but then you audit everything they do. And one of the other threat vectors to think about is sometimes root users, and especially APTs, try to escalate privileges to become an intended user. That's a real common threat vector. I'm going to go in as root, I'm going to escalate my privileges so I look like a legitimate user and try to grab the data. So we have the ability to stop that and alert on it. So you know, we're root aware, so you can't escalate your privileges if you're using our policy or our agent here. So here maybe you want to audit everything they're doing just to see what's going on. And then the third line is anybody else. So anybody else is trying to access the data, you just deny it and you audit it, because if there's an unauthorized user or process trying to access data over and over again, you probably want to probably something suspicious, unusual going on. So you have the ability to stop it and audit it. Excuse me for just a second. So once you define a user set, user group, and then a policy, you can get very granular on where you want to apply that, what we call a guard point. So a guard point is that policy set, and you can choose where you want to apply. Do you want to apply to a file, a directory, the entire disk? Because maybe not the entire set of data in a storage pool where this is being pointed to is sensitive. Maybe just a subset is. Here, you look at the Couchbase example, right? The data files, the binary files, config files, et cetera. You can designate which path you want to protect, and so you can get very granular. And the biggest use case is maybe not all data is sensitive. Maybe this data is mingled with other data and some other type of application or database. So again, you can get very granular on what you want to do. And then one of the things you can do is this is really what enables encrypted backups. It's one of the problems that Don talked about. But again, if you have OS administrators that all they do is back up data, guess what? Now they have the ability to back it up, but it's just encrypted, A, and then B, you can send that data to the cloud or any other place, and it's all encrypted. So a lot of our customers do encrypt DR, but they use us to encrypt the data, but they can put it on Amazon or Google, whatever cloud of their choice is, and the data is encrypted, and they own the keys. So even if they want to move from one, say, cloud provider to another, they basically have the key and just can destroy the data. Nobody else can view the data. So it's a good way to be able to protect the data and not be locked down to a cloud vendor and move workloads around. So now let's, again, going back to the population set we talked about. Let's take a look at this. So this is the Couchbase approved user, and here you see that they get access to all the data. They can see the metadata. They can see the actual database data, et cetera, and they can do their job. And we have pretty granular logs. I'm not going to ask you to read all the text down there, but basically it audits all the activity that's going on. And this second one is an example of a privileged OS user. You see, what's different is, again, they can see some of the headers and some of the metadata, but they don't actually it's all ciphertext. So again, this ability to access it, but not actually being blind to the data. So again, if these guys need to do backup or any other thing, they can do it, but they don't actually get to view the data. They can't copy it, et cetera, to do bad stuff with it. And the third is obviously very simple. It's any unauthorized user that doesn't meet the criteria you define for either accessing or viewing the data. They're just denied, and essentially they just you can log this and send it off to whoever might be concerned about this. So that was the I guess the meat of the presentation. And so just to summarize, I think we heard all the sessions today. The reasons people use Couchbase, it's a really powerful NoSQL platform, very high performance, and performance again is not just Couchbase, but all the other parts of the ecosystem they interact with. And so again, we want to, from a transparent encryption perspective, try to make it transparent as possible, not only for a development perspective, but from a performance perspective. And as I talked about earlier, I mean, data security is huge, or protecting data at rest. That's the typical. If you use a Verizon report or a FireEye report, that's where a lot of the theft is happening, when data is sitting at rest somewhere and somebody's got access to it they shouldn't have, and so this is what's driving a lot of data breaches. And so our advice is to address it proactively versus doing it reactively. We see this all the time, and then we've partnered with Couchbase to help optimize our integration with them, and we do performance testing, et cetera. So try to make this as easy as possible for you guys. And then Don, I think did you have a last slide or? Feel free to ask questions as soon as Don finishes up here.
Yeah, so just the last bit of stuff here. So don't forget to fill up the Connect survey that we have in your Connect app. There is also, you can, all that you saw today, I hope you liked some of the, the setup and the workflow here. But you can try out our beta build of Couchbase at this link here, as well as don't forget you can try out the Vormetric, test drive Vormetric with that solution and see and try it yourself what we kind of saw through that link as well. And finally, there's training as well if you guys are interested.
Yeah, and then obviously we have a booth here, so feel free to visit the booth. We also have we did a survey for a lot of CIOs and on insider threats, and which Couchbase sponsored, but the #1 place they're concerned about where sensitive data resides is databases. So again, a very relevant topic. It's a lot of CIOs and CISOs are concerned about that sensitive data sitting in databases and how to protect it. So we have that paper available. Yes.
So do you have any performance metrics like with Vormetrics, without Vormetrics for the Couchbase?
Yeah. So we have that for a variety of variety of technologies. We're working on the Couchbase one, but for example, we have some NoSQL performance data. We have some HANA performance papers. We have database performance, structured database. But yeah, so we have a rich set but we're working on with Couchbase one for something very specific to Couchbase.
Yeah, we don't expect that to change too much compared to other vendors because given that we just understood it's a transparent solution, there are no hooks that Vormetric has to call in within the Couchbase engine itself. So it's directly at the file system layer, and you just encrypt. One way to think about it is you need to figure out what are the files which you may have sensitive data. And if you go to our best practices, we did come up with like a suggested set of paths. For example, your data path, your index path. There are some configuration files like your password file. Although the passwords are hashed, you might want to encrypt it to kind of get maybe another layer of security on top of the hashing, which is again a one-way function hash, right? So there are some best practices where you can kind of you don't want to maybe encrypt all your data, but you want to encrypt like bits and pieces of your data. And also with application level encryption that we talked about, you may want to identify parts of your app which are holding sensitive information. Let's say a particular document which is storing user information or user profile information. You can call in use Vormetric and call in the DSM to kind of encrypt some parts of the fields and then put it inside Couchbase, which means then that you don't have to do that other layer of encryption on your disk, assuming you have done application level encryption for all your sensitive data. Right?
Yeah. And their performance is typically measured in operations per second or transactions per second, right? So it's a little bit different.
So mainly because yesterday, like when we did a conversation, the idea is like the Couchbase we use for performance at milliseconds. So any additional millisecond will count here. So that's why I was checking with you guys. Like if you have any performance metrics like with plain Couchbase,
Yeah.
Couchbase internal security, and then Vormetrics, like
Yeah.
three layers of
Sure.
degradation you have to see. Right?
So that's what we're working on, and
Yeah.
So, yeah.
So I think the question is, do you have performance papers with Vormetric and without, essentially? And that's very common. So again, when you introduce encryption in the equation, it's a math issue, right? So there's going to be a little bit of overhead, and that's a very common question. So again, if you go to our website, you'll see that's pretty much what we do. I mean, that's the #1 question people have. So there's a lot of performance data, and we're working with Couchbase because there are other types of data like Couchbase that we show performance data for, and quite frankly, it's faster because we have a layered file system, and sometimes it's faster with Vormetric than without. So.
Any comment on the licensing part? Like how
Yeah.
does it work?
Yeah, sure. Very good question. So the way the licensing part works is, so there's the best way to think about it, there's two major buckets here. So one is that data security manager, which can be a virtual appliance, it can be a physical appliance, Sometimes people want HSM cards integrated, so a lot of financial services and government end users, because it's housing keys, they want a HSM card, which makes it tamper-proof. And then that's one bucket. So that's typically about 10,000 to 30,000, depending on what, and typically people want at least 2 for high availability. That's, because one goes down, you want it. And then the other major component is the agent part, and that literally scales based on the number of nodes. So so that one is typically about, we have volume pricing. I'd say probably $3,000 a node is a good rule of thumb for that. Yeah. Any other questions? Yes, so the question was, do we support open source MySQL? We do. We're fairly, again, we're transparent, so we're fairly data agnostic. So people use us for unstructured data, structured data, data warehouses. So we've got a variety of data types we support. Yes? So the question was, how many units do you have to have before you qualify for volume pricing? I don't have the price list on top of my head, but I think the minimum is it 5?
It's a little more than 5.
Okay. Maybe we can talk offline. I can fire up my computer, but yeah. Yeah. So there's 2 ways to consume. So again, we have large enterprises that consume our products across the enterprise, but we also have some folks that maybe just want to secure a couple of nodes here, a couple of nodes there. The other way to consume our product is there's a lot of cloud service providers that actually offer our product as a service. I mean, and in pure play as a service. And so if you want to, they'll have the data security manager at their site, and they'll just basically charge on a monthly basis the ability to protect data on certain nodes. So that's another way to consume. Sorry? Okay. Yeah, I mean, I'm just suggesting it as another form factor or another way to consume Vormetric.
So continue on the license.
Yes.
Like Couchbase has 2 parts, right? One is the cluster itself.
Yeah.
And then a client you can have, let's say you have a cluster of 2 nodes.
Yeah.
But you have a 30 nodes, which is the client accessing that app, Couchbase. So your agent is on the server side or on the client side?
Yeah. So it'll be on the server side. Yes. So the question was, will our agent be on the server side or the client side? It'll be on the server side. Yeah.
So the licensing is on the server side. So let's say I have
Yeah.
2 nodes of cluster of Couchbase. So the 2 nodes license I have to pay for Vormetric, and the agent, which is client library, is part of Couchbase.
Yeah, so there's 2, if you look at it from the Couchbase angle, right, there's 2 parts of it. There's, and the application level encryption is the second part. The first part is on disk encryption. So on your cluster side, you might want to encrypt things that you store on disk. Just that if there's an attacker who pulls a disk drive and runs away, all that data is encrypted. So that's an agent which resides at the file system level, right? So the second agent is the one that if you want to use application level encryption, that's an agent that sits at the application server, right? Because you have to make a call or use Vormetric API. So there's 2 APIs in play there in that picture. The diagram we showed, you have the Couchbase SDKs, which are just doing reads and writes to Couchbase. But you also have this, the Vormetric SDK, which is on this side. So the Vormetric application encryption is using the Vormetric SDK to then talk to the DSM. So you have 2 calls there. You first have to call to the DSM, encrypt decrypted data, and then pass it to the Couchbase SDK to write it in Couchbase.
So if you are doing client-based, then you have to do client agent.
So the question is, if you have to do, if you're
Yeah.
doing client-based, do you need a client agent as well?
So it's just the application is using the agent is making calls to the DSM. So it's at the application layer, not the client layer for field level encryption. Does that make sense?
So application level, if you're doing application level encryption, 1 agent there. If you're using on disk encryption on the server to encrypt your data files, index files, and you need an agent there. Yeah.
Yeah. Yes. Did you have a question? Oh, sorry. What? Yes, go ahead. No question. You just went. Hi. All right. Anybody else have any questions? Yes. Yeah, so typically, So the question was, if you have two types of agents, do you have to put? Yes, you do. So typically what people do is go with the first approach, which is transparent encryption. And as they identify certain apps that they want to, again, have that field level encryption for, that's where they start bringing those in. They don't kind of boil the ocean at once and say, I'm going to do all these apps and all these servers at the same time. Typically what they do is, do the file level encryption to kind of reduce the attack surface, and then they move up to certain applications, and then they start, doing the field level encryption at that. That's what we've typically seen. All right. Any other questions? They're good questions. Thank you.
Okay.
All right.
Thank you.
Thanks very much.
Yep.